This talk kind of came to me because in the last 2 years, I've seen a lot of guides on how to do GraphQL, kind of tutorials on how to get your project started and queries, and there's a lot of material on how to design resolvers, how to type the resolvers, but there wasn't that much about what does GraphQL implies for, like system design and architecture, and how do you design a system containing GraphQL. And the thing about GraphQL is that even if on the GraphQL website, the definition is basically that it's a query language with a server-side runtime, there's a lot more inside it. There's a lot more patterns, there's a lot more paradigms, and there's a lot more principles that are embedded in the way how GraphQL works. And if we are able to understand which these patterns are, which are the principles behind it, then we're going to be much better at predicting and anticipating how the system will look like and what the limitations will be, instead of kind of reinventing the wheel. So when I started back in 2017, it felt like GraphQL was this new thing, and there's nothing like it. And there's, everything is new, and there were so many talks about, but then you realize that what's behind it has been around for a long while. So although GraphQL influences architecture uniquely, the way things are put together, it's quite unique, it builds on well-known design patterns. And if we are able to identify these patterns and know them, we're going to understand much better GraphQL. We're going to be able to onboard people much faster, and also defend architecture choices to the stakeholders around us. And so that was quite of my motivation. And so if we take a look at GraphQL, at least the JavaScript implementation with Node, the one that's been running, but they're pretty much all the same, you will see that you can identify a couple of patterns that are being used heavily and kind of being enforced on our system by using GraphQL. And the first one is definitely the API gateway pattern. And then there's two database patterns that have been around from the late 2000s that are being kind of merged and transformed. And then I wanted to talk a little bit about the backend for frontend pattern. And so let's just dive right in. And so first, the API gateway. So the API gateway pattern, it's something that has been used a lot outside GraphQL in microservices, also mostly together with a proxy pattern. And what it does is that before using a API gateway pattern, the main problem is that we have a client, like that was the traditional REST, let's say REST architecture. We have a client, and there's a couple of backend services. They can share databases, or they can have their individual database. And so the client is just kind of talking to and making requests and developed against those microservices, which leads to having service client coupling, having too many round trips, so too much data usage, and having redundant edge function. And so the solution traditionally to this, even before GraphQL, was to use the API gateway pattern, which basically will work like the facade pattern in objects-oriented design, and kind of hide the implementation of our backend APIs from our clients and offer a uniform interface, which if I just say it like that, you probably think, oh, that's GraphQL, right? And so you can see already that what GraphQL did is to reuse the API gateway pattern and bring it with the type definition and the query validation and mix it up in an amazing tool that we're using. And so, of course, because of this, we are able to do request routing. We're able to have API composition, so using the composition pattern behind the proxy. And we only have to implement edge function like authentication and catching just once, right? So that's awesome. But the API gateway pattern also has certain limitations that we can anticipate if we know that GraphQL implements this, without having to ask ourselves, oh, how do you do catching in GraphQL? Like, it would be a totally new thing and we'd have to reinvent the wheel. And so we know from the learning from the past, for the people using this pattern so much, that the API gateway pattern will introduce a unique point of failure. We have this central point in our architecture that it's basically all or nothing, so it can fail easily. And because all the requests and the development goes through this new unique point, it can quickly become a development bottleneck. And I experienced this real life, let's say, in the last 2 years. and realized that in order to develop well with GraphQL, you have to change the thinking and you have to prioritize schema tasks and schema development and mocking in a different way. If you don't do that well, everybody will be pending on the release branch of the API in order to develop their clients against it. And so you have to be aware that with the API gateway pattern in place, you'll have to implement new strategies for vertical and horizontal scaling for the central node. It's a node that has to be highly available, and you will be releasing that node a lot. So probably you're gonna make a lot more changes in the main GraphQL API than in any of the microservices. And so your go-to release or go-to live for this node has to be really well implemented and really solid. If something fails there, you're pretty much done. And so that was the first one. And now we're gonna go a bit into more data side. So GraphQL makes a lot of promises on how our business will be modeled and how we're gonna use types for everything, and we're gonna have this unique place to have all our business mapped out. But these patterns are nothing new. So this idea of the enterprise being mapped to a single model has been around since the 2000, and there's been a couple of products that have been released based on these ideas by IBM and so on and so forth, and a lot of lessons that have been learned. So we can apply this to GraphQL today. And so one of the patterns is the integrated database. And what the integrated database promises is that we will be able to have 2 or 3 applications basically sharing and living on the same database using the same schema. And the reason we do this is because even if these applications don't use the exactly same data, they do share, let's say, part of the data. And so it would be much easier to have synchronization. There's no need for an integration layer. And we're going to have faster rollout if we just use one database cluster that exposes directly against these 3 applications. And this sounds a lot like GraphQL. You have one GraphQL server, you have several clients, and you're basically developing against it. Well, not against it, with it. But this pattern introduces a bounded context violation, and I'm going to talk a bit about what that means. And also, on the long run, so even in the short run, you become much, much faster, and maybe in middle term. In the long run, the complexity in development increases. And the reason being is that the 3 clients, they all live in different universes, they have different requirements, and even if they are not directly coupled, because they are all kind of dictating requests on the same space, and we have to accommodate all these requirements in the same space, they end up being coupled, let's say, like deep coupled, indirectly deep coupled, I would say. And so this is kind of a practical example. There's many that you could put, but in the last 2 years, I had the experience that I would find myself with things like this. So front-end will pretty much go to our GraphQL, amazing GraphQL tools, and they will have the amazing autocomplete tool, and they will look for an amount, and there will be 5, 10 amounts. And the answer was always, they would always ask, why don't we unify these things? And the reason is each single entry for amount will package different business logic, and they will be used in different clients with totally different formatting, but then they will be all accommodated in the same schema. And so we kept running into this problem. And the other problem was that we had to make these types super generic. So of course you could say, well, we could just take this out, but then you'll end up having types that are super generic because you still want to accommodate lots of different requirements in the same place. And so there's always a counterweight to everything we do. And so Martin Fowler, I'm a big fan of Fowler, and in 2004 he was talking about database styles and analyzing the integration database, and kind of said that the links between these applications become really brittle at the database level. And so in the long run, it's going to be really hard to introduce changes. So the system, even if we have an increase of speed in the short term and middle term, in the long term, things become much harder to change. So that was the integration database pattern, and now I wanted to kind of finish up talking about the data federation pattern. And how many of you heard about the Apollo Federation? Okay. Did anybody use that? Oh, congratulations. The baby too? Or did it together? Okay. So basically, the data federation pattern, it's a pattern for IBM enterprise applications. They did it back in the 2000s. They released IBM Saver based on it. I guess at some point it died, or maybe it's still alive. But what the pattern refers to, it's the ability to put together subsets of different schema, unify them into one single federated schema, and then be able, as a corporate or enterprise, to develop all the consumer applications in front of this federated schema, right? Which, again, sounds a lot like GraphQL. You have one schema that models our whole business model, and we're building clients against it. We're bringing clients around it. And so this is theoretically, this is a really nice idea, but people have been using this in production for more than 20 years, right? And so there's also a lot of lessons about the federated schema that we can pick up on when we use GraphQL. And so the advantages of this pattern is that we could use different data sources that are totally non-related. Maybe they even implement different query languages or database technologies. We will put them all together in a uniform interface, and so governance will be much easier in the enterprise. So agreement will be much easier to agree and to be synchronized, and not to develop in parallel and make sure everybody talks about the same thing and apply domain-driven design and so on. And you're going to have this unique map, this idea of the unique map of the corporate, where we map all our business into one big schema, and you can navigate the business by navigating the schema, right? So again, sounds a lot like GraphQL. It's been done 20 years ago. But of course, people, as they use this pattern, they actually also realize that it comes with trade-offs again. And the biggest trade-off, I would say, is that in order to make this happen, in order to have all these different schemas merging into a single one, you're going to have to use not only non-trivial merging strategies, but also sophisticated tooling in place. And that's what IBM and so on were doing back in the days for the corporate customer. You're also going to need more generic data structure and a lot of negotiation on how that types will look like. And so all of a sudden you have a board that owns the kind of the schema, and they are negotiating all the time, and then they're bringing that to their teams. But the bottom line here is that we have different database technologies, different backend teams, and then different clients, and they are all stretching on the same federated schema. And so it's not that easy to make everybody happy. And so you probably already asked, who used Apollo Federation. I haven't used it in production, to be honest, yet. But the promise, it's amazing, right? We're going to be able to separate our concerns. We're going to be able to have a distributed graph. And then we have amazing tooling and amazing directives to put everything back together and to be able to have this distributed graph and orchestration tools on top. Of course, it comes to the price, and I've been running this at least locally and looking at the demos, of quite a steep learning curve, I would say. So I've been using GraphQL for 2 years, and it wasn't that straightforward. I think it's a brilliant technology. I'm really looking forward to see it working. But when it comes to actually teaching that or bringing it to us, you do need to have a certain level of GraphQL knowledge and directives in order to be able to be productive with it. They're still at the beginning, so it was released a couple of months ago, I would say. They announced it at the GraphQL Summit last time. Some of the corporates are already using federation with GraphQL by themselves, and so that's why Apollo kind of switched into it. But again, Phil Calcao, he's one of the SoundCloud kind of engineering team members back in 2012. He reviewed GraphQL in 2019, I think in July, and kind of agreed that given that there's so many applications, so many users, and so many teams, it's pretty hard to believe that one single schema will be able to satisfy everybody without using some non-trivial sophisticated tooling to make that happen, right? And so gonna come back to, you might be asking, well, what do we do? And so there's already a lot of solutions out there, and I wanted to talk shortly to wrap it up, talking about the backend for frontend, which I believe it's a really nice solution without going into sophisticated tooling for the problem we're facing when our schemas get too big, instead of federation. And so this is how the backend for front-end patterns look like. There's a hand implementation, but this could be one of them. And basically what it means is we are going to build our backends with our front-end in mind. And so it's basically the front-end team that owns our backend. And then our backend will be based on GraphQL, but it will be really tied to the client. And then it will use the context, the uniform context that microservices give. And so in this way, at least, we can separate concerns in terms of clients, which is where most of the concerns comes from, and be able to get some speed in the long run at the price of having repeated code. So you will have to implement things twice. You'll have teams that implement kind of the same product entity, teams that implement the same price entity. But that's, I believe, after my experience with bloated types and so on, I believe that this architecture choice is going to make it much easier for the developers working with it to go faster in the long run than the sophisticated tooling. We will see it out. And yeah, this is pretty much it. Hope you enjoy it. Hey, he did. So a little spoiler for you. I'll be joining Klarna, so that's a surprise. In November, and yeah, I want to have a little discussion because of course design patterns are something people used to discuss on. And so I don't know how much time do we have?
Yeah, we have time for a few questions.
Yeah. Or
yeah.
So do you guys have any question, any experience that you wanna? Okay, so we start with number one.
Yeah, I would like to ask. A couple of months ago, when I tried to wrap my head around this GraphQL thing, it was really hard to find resources beyond some basic tutorials. So what would be your advice on getting knowledge on this design, architecture, scalable solutions from?
Okay. So basically, there's a lot. There's not so many. If you look for GraphQL architecture, you're not gonna find much, right? That's why I kind of begin to ask the different question and try to look at the things that are already there. And then there's infinite literature on these patterns. So you can spend weekends reading about it if there's nothing else to do. And then try to understand how GraphQL is using them. There's already a couple of voices because Apollo Federation, the idea is that the name is federation, so data federation is the same pattern. So that's already like a hidden hint. But I would try to look into these patterns and understand that what GraphQL does, it's building on top. There's this quote by Newton, right? If I've seen fighter, it's because I stood on shoulders of giants. And so it's basically building on top of a lot of iteration. It's not the kryptonite found on Mars, like, wow, we found GraphQL. It's nothing before. And so this is what I would go for. There's a couple of papers on GraphQL architecture. People are starting to realize that it's a lot more than just the type system. But I guess the best recommendation I have for you is just talk to me, and then I'm going to forward you a couple of links. Okay.
Hey, my name is Kirill. I want to ask regarding data federation.
Yeah.
Is it really practical to have some kind of namespace for each microservice, which is then federated into one, like having you had better picture with GraphQL, I think, with some names like preview or
this one you mean?
like what it allows, for example, microservice which belongs to orders and have nested level like orders and everything inside, and then payments and everything related to payments microservice inside, and like build a schema which has a lot of nested levels, and each sub-level belongs to each microservice federated into one schema. So would that work, or is it better pattern to combine everything together?
So if you want to take advantage of the unique schema, it doesn't really matter how much you nested it. In the end, we are reusing, right, the same objects, because you can dive in the orders. For example, you mentioned the order, and then you're gonna have at some point some price object that you'll reference back to the service that actually handles pricing or products. So the unifying the schema already, it doesn't really matter how we nest it, it will already place this boundary. If you have like 3 entry points and they all just redirect to independent services with independent types, then of course that's doable, but at that point you're just using the capability of the API gateway, right? We're not using the mapping. If you're not reusing types, we're not taking advantage of the schema, of the unique schema. So the point of the unique schema is reusing types between different services. Once you want to take advantage of that, then it gets complicated, because then you have all these directives that are like require, extend, and they are cross-service, and you already need to know a lot. If you're a GraphQL developer, even I had so many issues trying to get myself on board with so many. There's already 4 or 5 directives in GraphQL. They're adding like 5 more, and then it already looks like so enterprise. And so, you know what I mean? Like once you want to take advantage of it, you're already having the disadvantage. If you're only using the API gateway to have the request routing, then yeah, that will work. I think that was your question, more or less.
Yeah.
If you can just use the API gateway pattern instead of going deep into reusing types. Welcome. And the baby? No. Okay, well, thanks a lot. And if you have any question or suggestion, or if you use GraphQL and you felt like some of the problems I mentioned, you identify with it, feel free to ask and we can discuss about it. So, thank you.